Hello guys, this is the second part of the regex. Let's get started. So the first thing that we want to know about is the associated language to regexes. We already know the meaning of the associated language to a machine. It's the set of all strings that can be recognized or accepted by that machine. And for the regexes, it is reasonable to say that whatever it can represent, right? So we define the associated language to regexes as the language that the regex represent, and we denote it by this guy, L of R, if R is the given regex. Here is an example. R equal to AA star. We already know that it is A to the 2n such that n greater than or equal to 0. It means that 0 or more concatenation of AA. Okay, our next definition is the equivalency of regexes. When can we say two regexes are equivalent? When both of them have the same associated language, something like this. So if L of R1 is equal to L of R2, then definitely these two regexes are the same. So we can visualize this concept with this. R1 and R2 are equivalent if both of them are representing the same associated language. Let's take an example here. Look at these two regexes. R1 is A plus B star A. R2 is A plus B star A plus B star A. Okay, are they equivalent over this alphabet? Yeah, let's see what languages they are representing. So if you remember, we said A plus B star is anything. It represents all strings. In fact, it is representing sigma star. If we want to find out what language is this, then we would say it is W A such that W belongs to sigma star. So this is the L of R1. How about L of R2? We can find out what language it is representing. A plus B star is again W. A plus B star, yeah, not exactly W. We can represent it with something else. And then A such that W belongs to sigma star and U belongs to sigma star. Are these two language equivalent? We can think about this. WU, W. Here we have two sets that are being concatenated. What sets are they? W is everything over this, right? So if we enumerate the W that is sigma star, it will be lambda A, B, A, B. You remember this, right? It is all strings that can be made by concatenating zero or more of these symbols. All right, so this is ERW, whatever this W is. And it should be concatenated with the same thing, lambda, A, B, and blah, blah. So if you concatenate these two, what we get? Can we make a set bigger than this, whatever it is? Not really, right? In fact, sigma star and sigma star, when we concatenate both of them, we will get sigma star because this is the biggest set that we can make with A and B, all right? So it means that I can replace these two with one of them. Okay, so if we do this, then WA, WA. So it means that R1 and R2 are representing the same language. So that's why we say they are equivalent. So theoretically, we can say we can have infinite regexes for a given language. In this section, I want to show you a few identities about regexes. Of course, there are more, but I just picked some of them. If R and S and T are regexes and A and B belongs to sigma, then we can distribute a regex inside a union of two other regexes. And as you see, it looks like the elementary algebra. It can be RS and RT from the left. We can have the same thing from the right, okay? How can we prove this? We need to prove that L of this guy is equivalent to L of RS plus RT. And how can we prove this? We can prove this by using those 7 rules that we learned in the previous lecture. Okay, we are not gonna go over that, but for practice, you can do it by yourself. All right, another one is this guy. What is this? A star and then again a star is equivalent to A star. It means that both of these two guys are representing the same language. Is this the case? Yeah, we can, intuitively, without even going over the proof, understand that this is true. So, what is A star? A star is all strings that we can, by concatenating 0 or more A, create. So this guy is, we understand that it is a lambda, A, and so forth. Okay, now what would happen if I put a star here? It means that I need to concatenate this with itself 0 or more. This is an infinite set, and if I concatenate this with itself several times, can I get something more than this? Of course I cannot. This is the biggest set that I can get by concatenating 0 or more of the A. So if you concatenate with itself, then you will get exactly the same thing, right? So that's why we would say that a star is equivalent to A star. And also for this one, so when we learn that what's the meaning of A star, if we concatenate A from the right or from the left, it doesn't matter. Both of them are the same. And we can extend this idea to these two. If we concatenate A with itself several times, let's say, for example, A, then a star, and then if you have an A here, it is equivalent to this guy. And if we have more, the same thing. So bottom line is we can concatenate A from the left or right to A star. And this is another one. So A plus B star, A star, if we concatenate this from the left or from the right, it will be vanished inside the A plus B star. Because when you concatenate anything with A plus B star, it will be vanished. From left or right, it doesn't matter because A plus B star is the biggest set that we can create with A and B. And here I explained that how you can prove all of these identities. All right. Okay, so let's take some quick examples. How can we use these identities? So look at this. A, B star plus B, B star. Here I can factor out B star from the right this way. You remember that? It's the left and right is important because we are talking about strings, and in strings, the sequence has a meaning, right? So AB is not equal to BA. Okay, so I factor out the B star from the right, and then from the first one, we get A plus and B. So in this way, we are using the identities to make the regexes a little bit more compact. How about this one? So we have B star here, B star here. If I factor out it from the left, then what I get here, so there is nothing here. I cannot leave this blank, right? Yeah, we can say that it's lambda. This is another way that we use the lambda. How about this guy is a A? Okay, so this is the big one. So first we look at this. We see the A here. How about B, B star? I can factor out the B, B star from the right, and then I get A star plus A star B. All right. I feel that there is something here that I can factor out. Do I have a star? I have a star here, but in the wrong place. Can I do something here? Of course I can do, because I already learned that a star is equal to a star A, right? So I can replace this guy as a star A plus a star B. And on the right side we have BB star. Okay, now I can factor out this guy from the left. So it will be a star, A plus B, and B B star. So as you see, we can play with those identities and make the regex a little bit more compact and more understandable. In this exercise, I ask you guys find out what language this regex is representing. In this section, we want to sharpen our knowledge about regex by converting languages to regexes. Let's get started. So how can we create a regex for this language? Yeah, usually if we can provide the set builder for that, it would be easier to convert it to regex. So all the strings with exactly one A, we had this language before. Exactly one A, it means that before this A we can have any number of B's, and after that we can have any number of B's as well. Of course, the dummy variables are different, right? Okay, so what is the regex for this? Any number of B's can be converted to regex like B star, A is A, and this is another B star. All strings with at least one pair of consecutive A's. So at least one AA, it means that before that we can have anything, after that we can have anything not necessarily equivalent, right? Okay, so how can we convert this to the regex? This is anything AA and another anything here. So the regex for this language would be this. For this one, we have two constraints. One for n, this guy, and one for this guy. Okay, so let's start from the a to the n. It is saying that it should be greater than or equal to 3. So it means that we have at least 3 A's. Okay, so at least 3 A's, it means that we have AAA And then after that, we can have more A's, and more A's will be A star. How about the B to the M? M is even. Yeah, we already had that. So that means that any number of BBs. So this will be the regex for this language. For this one, we have a little bit more complicated constraint here. Yeah, let's start from here. The size of the W, the strings, is greater than or equal to 3. So let's say this is the string, one symbol here, here, and more here, right? So this constraint is saying that the third symbol of W is A. So we already know that it is A. And how about the rest of that? We don't have any constraint for that, so it means that it can be anything. How about the first two? It doesn't say anything, so it means that we can have something here and something here. But what can we have here for the first symbol? We can have A or B. How about the second one? The same thing, A or B. The third one is A, and after the A, we can have anything, and we already know that it means A plus B star. The regex for this language will be this. Now, again, we have a little bit more complicated constraint here. We have A to the N, B to the M, but we know that N plus M is even. How can I simplify this? Yeah, I need to think that how we can add two numbers and get an even number. I mean, what conditions these N and M can have to add both of them to get an even number? Yeah, we have two possibilities. Either N and M both are even, or N and M both are odd. That's a good hint to break this language into two languages. How? The first language would be A to the N, B to the M, such that N and M are even, right? Between these two guys, there is an OR, so we translate that OR to union A to the N, B to the M, such that N and M both are odd. Now we can translate this to regex. So A to the N, B to the M, N and M are even. We already know that it is A star, B, B star. So this is for the first language, and we translate this U as the plus. And how about this? A, A star A, B, B star B. We are using our knowledge about the previous examples. So I put some exercises here. You guys can go over them and try to solve them. In this section, we want to find a relationship between regexes and the languages. You know that we are always interested in finding out this relationship or association. Yeah, we ask the same question between the machines and languages. In fact, we want to find out that what portion of the languages will be covered by regexes. So this is the goal of this slide. Here is the question. We have all regexes inside this set, and then we have all of the formal languages here. Now the question is, what portion of these languages will be covered by the regexes? Is this the case that every regex will represent a language? Yes. How about the other way around? Is this the case that every language there is a regex for that? Yeah, that's something that we really don't know. Our knowledge at this moment is not enough to respond to this question, but we will get that knowledge shortly. Let's try to create a regex for this famous language or celebrity language, A to the N, B to the N. You may pause the video and try to find a regex for this. After some struggling, we realize that it is impossible. Why? Because the same problem we had for the DFAs. How can we make sure that the number of A's and number of B's are equal? We don't have that much power in the regexes. The only thing that we have is A star and B star, and we know that the number of the A's and B might be different, right? So we don't have any tool in regexes to represent this language. So this is leading to this idea that regexes are only for regular languages. Yeah, this theorem is actually is proving this. If R is a regex, then L of R is a regular language, and vice versa. If we have a regular language, we can find the regex for that. So this leads to a new way of defining regular languages. We come up with a new definition. A language is regular if a regex represent it. Before we had a language is regular if we can construct a DFA or an FA for that. Okay, so now our knowledge is enough. All regexes are pointing to the regular languages. So non-regular languages won't be covered by regexes. Now, if I ask this question, what is the next step? Absolutely, we need to find another practical way to represent the non-regular languages. So now we know the limitation of the regexes. I put an exercise for you guys. So I ask to fill out these three tables to make sure that you understand the meaning of all of these operations. All right, I'm gonna stop here. See you guys in the next video.